Hello, everyone. Thanks for joining and this workshop. So this is just a reminder that it's a hands-on workshop this time, and really value you guys joining us. So welcome to our workshop, Build a Recommendation System Using SingleStore Vector Search. And my name is Yukti Dwivedi, and I will be your moderator today. One of my main jobs here at SingleStore is to organize weekly AI webinars, virtual events, or a workshop like this one. We organize 2 or maybe 3 events per week. So we demonstrate different data and AI use cases and new tools and technologies. I also post about our upcoming webinars here and now. So if any of these topics are interesting to you, feel free to connect with me to stay in the loop. And I'd also love to hear your feedback or ideas on topics that you would like to see in the future sessions. So please feel free to connect with me and drop a message to me on LinkedIn. Speaking of future sessions, we would like to tell you that we have got multiple informative new webinar sessions that are coming up. So as you can see on your screen, we are presenting on 26 how to talk with your SQL data with function calling. Again, this we will try to keep it also hands-on, and our technical evangelist and our CMO Madhukar will be joining, and will be helping you out with this particular subject point. And on August 27th, we have a partner webinar, Achieve Near Real-Time Analytics on Amazon DynamoDB with SingleStore. And August 28th, on popular demand, Beginner's Guide to RAG with Professor Tom Ye. He's from University of Colorado. And these webinars have always got hundreds of attendees and thousands of registrations. So feel free to check these out. The links of the landing pages are now live, and you can scan the QR code, and I hope to see you all there. Please RSVP right now. So coming back to today's topic, you're welcome to participate in the discussion throughout the session using the Zoom Q&A button. It is present at the bottom of your console. Just an FYI that we do not take questions if you try to raise your hand. So if you have any questions, just feel free to use the Q&A button, and we will try to address your question live. Akmal is here to help you with that. So this has gotten a little difficult over time because sometimes these questions can't be taken live. So we have an email address, and you can reach out to us there, and I'll put everything in the chat. Just make sure that you have logged into Zoom with your actual name and your email address, because we will not be answering any anonymous questions. Moving on, we'll love you all to have a dynamic experience during this workshop so that it's easier for you to follow along. So to encourage everyone, feel free to try out SingleStore notebooks. Anyone who tries it today will be entered for a chance to win either branded new AirPods Pro or Meta's new Ray-Ban LLM smart glasses. It's absolutely the winner's choice, who will be selected by a random draw. Simply click on the link that's present on your screen. I will put everything in the chat, or you can, if you want to do it now, just scan the QR code and just simply log in, create your organization. You may know that SingleStore has had a free trial offer for many years, but just in the past few weeks, we have also announced a new free share tier, which we will talk about a bit later today. So moving on, allow me to announce our speaker today. We have Akmal Chaudhary, who is joining us from SingleStore. He's a very regular speaker at our webinars and an expert when it comes to data science use cases and AI. So hi, Akmal. It's a privilege to have you, and thanks everyone for joining this webinar.
There we go. Unmute myself. He started speaking without a microphone. Okay, so thank you very much, all of you, for joining. Now, keep in mind, okay, we have scheduled 2 hours for this because it's hands-on and because there's some setup, okay? And then we can work through it together. Now, in terms of the agenda, you can see essentially what I'd like to cover in the slides. Okay, so there are some slides to show you, and we'll get through those fairly quickly, okay? Because I want to leave time for you to create your accounts, upload the notebooks, and then we can start working through this. And so we'll begin. So Yukti will post in the chat a link for creating the free shared tier account, and you can actually access the standard account as well. Okay, so it will look something like this, the cloud trial. Okay, so if you have an account already, great, please log in. Okay, we'll be sharing the link to the GitHub repo with you shortly as well. Okay, because you'll need the assets. And within the GitHub repo, there are IPython notebooks. There are also PDF versions of the IPython notebooks. That's just for safety, okay? given my experience yesterday, so if you attended, you'll know that it's kind of Murphy's Law, okay? Anything that can go wrong will go wrong at the worst possible time. Sometimes outages happen, network problems occur. It's, act of God, I think they call it in insurance world. And so in the event that we, short of losing total internet connection, in which case it would be a very short webinar, we do have an alternative way that I can talk through the PDF versions of the notebooks with you, okay? So if there's some problems that we can't run today, but you have all the assets anyway, okay? So that's the key thing. And one thing I've learned as a presenter, I mean, try your best to be prepared for all possible scenarios and circumstances. It always surprises me when something goes wrong because it's something I never thought of, or, something that just kind of like an edge case, okay? It's very strange. So please sign up for this, okay? And what I did earlier today, just to kind of go through this process of creating a free account, they've changed it a little bit since I created an account a while back. So I thought, well, let me try and do one just to see what the experience is like. And so I opted for this first name, last name, and it says company email address. Actually, it allowed me to use a, you can use a Gmail or a live.com or a Yahoo email address. I think they prefer the company email address, but don't tell them that, okay? So, and then just do continue. And once you do that, I think it just asks you a couple of questions, really simple and straightforward. And then you get a link, I think that's sent via an email, and you can create a password as well. And once you do that, you get into your account. And I'm actually using that very same account that I created earlier. It will look something like this, okay? So this is what you need to do, okay? So please take the opportunity to do that. So if you haven't got an account, just follow the link that Yuxi's provided. You won't miss too much in terms of the slides. Okay, so I'm going to talk through a little bit so you can multitask and in the background, just set up your account, have that running. By default, what the engineering has done now, which I think is very useful, rather than you having to create any sort of compute resources automatically, if it is a new account, you will find that you get this starter workspace created for you. And that's exactly what I found, that as I logged into the account, I found to my surprise that I have a starter workspace and I have a database associated with that as well. So I don't have to even, go through the process of creating that. That is done for me. So all these assets are available immediately, okay? So that's the key thing. One other thing, and Yuxia, forgive me if you've done this already. She will share with you the link to the GitHub repo, which is actually will look something like this. Okay, so you'll see that we've got some data sets. Okay, there's the notebooks folder. There's the PDF versions of the notebooks. That's using NB Viewer, and then I just created PDFs of that. And some other things here as well. And if you decide to just download this from here under code, for example, you could just get yourself the zip file. It is about, I think, 25 to 30 megabytes in size, zipped up, quite small. So that shouldn't take too long. And then just unpack it in a convenient place for you, okay? And just be ready. Okay, so whilst you're doing that, let me get started on the slides again, and then we'll come back. So we'll try and work through these fairly quickly. Now, as I said a few moments ago, we've got 2 hours set aside. If you make great progress, or if you need to drop off for some reason, that's okay. No worries, okay? You are very welcome to leave. The 2 hours is the kind of limit of what we plan. If we finish earlier, that's awesome. I can have dinner earlier, and you can go away and do other stuff as well that will be useful to you. But anyway, let's get started. Okay, so quickly then, a little bit of background about the company, just to show you some key milestones. And again, you'll see if you're a regular attendee, you'll know I go through this fairly quickly. So company started in 2011. Previously, both the product and the company were known as MemSQL, okay? And subsequently added support for columnar store, okay? and OLAP. So originally, the focus was very much around in-memory processing for OLTP, online transaction processing. And with the addition of the column store, obviously, it didn't make sense to call the company MemSQL anymore, right? Mem implies in-memory, and then people are kind of associated it with OLTP. That's what it was known best for. And so the change in terms of name of the company as well, SingleStore. So today offers this concept of universal storage, which can handle both OLTP and OLAP. Okay. Today we're going to be using vectors. Okay, and vector capability has been in the product for some time, since 2017. It was a major financial customer, global, highly recognized company. If I mention the name, you know exactly who I'm talking about. For various reasons, I won't mention them today. Okay, but essentially, they came to us and said they needed support for vectors. Could we include that in the product? And we said, yes, we could do it. I mean, this was before my time, okay, before I joined the company. I think just to mention that, we are a company now with over $100 million in terms of annual recurring revenue and over 350 global customers as well. Okay. And then just this one, just to give you a little bit in terms of the high-level architectural view. So this universal storage that I mentioned. And then we've got a variety, excuse me, variety of ways that we can get data in. So yesterday, for example, you saw that we had a Kafka feed, and we were using pipelines, okay, using a stock ticker feed, for example. But that's one way to get data in. Siri is thinking that I'm... Okay, go away there. Transformations, okay, using Apache Spark, for example. And by the way, one of the notebooks today, number 5, actually has Spark. It is an optional one. We won't necessarily cover it, but just to give you an alternative way of kind of evaluating, if you like, the data that we've got, although we won't actually store that data in SingleStore, but that's something we can discuss later. And then sort of bulk load of data, whether it happens to be on an S3 bucket, for example, or maybe Hadoop HDFS, that's fine too. We do work on the major cloud platforms, okay? So AWS, Google Cloud, Microsoft Azure. Today, if you've got the free tier, it is very much on AWS. If you decide you want to configure yourself the standard tier, you have a choice of the other 2 cloud providers as well. You can run on-prem as well. There's a Docker container too. And in terms of data types, historically, I mean, relational is where the technologies come from. Yesterday, we looked at a little bit of time series, for example, and in the past, we've done geospatial. Notebook number 6 has an element of full text as well. Again, it's optional, but it just shows the power and the ability to combine semantic search with full text search as well. That's a very powerful combination. So that's entirely doable too. We have customers also using SingleStore as a key value. It's kind of unusual. I know of at least one that does that. JSON support has been in there for quite some time, even better with the introduction of SingleStore Kai, which provides MongoDB compatibility. And then last but not least, vectors, okay, which I've talked about already. So today we're going to be using the new vector type, and we can specify the number of dimensions that we want. And by default, it'll be 32-bit floating point numbers, although you can actually configure that if you decide you want another type. For example, integers, 8-bit integers, for example. Okay, it's perfectly possible to configure that for your needs. And then just to round off then, in terms of some of the applications areas, the real-time analytics, okay, dashboards, ad hoc queries, and so on. Okay, so we'll be looking a little bit at this. Now, everything we do is pretty much notebooks based today, simply to keep it simple, right? There's lots of other things that you could potentially do. For example, you could build yourself using Vercel or Streamlit, you could build yourself a nice application around this kind of problem in terms of building a front end to a recommender system. Absolutely fine. Okay. Unfortunately, today we don't have time to do that. Okay, but that doesn't stop you from exploring these ideas. Some of the ways that you could use AI and ML with SingleStore, some Spark, as I said, that's kind of optional, Notebook 5. We'll focus a lot on SQL and pretty much Python today. Again, don't worry too much. If your skill level in terms of these languages is not great, it's fine. I mean, the code is there. You just have to run it. The main thing is to understand the output that it's producing and why we are doing that, okay? And those are the sort of key questions that you need to think about. We will be using vectors. Out of the box, SingleStore supports two metrics, distance metrics. One is dot product, the other one is Euclidean distance. So yesterday, I think we were using Euclidean distance, if I remember correctly. Today, we'll be using dot product, okay? So that is another way that we can utilize. I think Veda, no, OpenAI, no, we're not using any of that today. All right, then. So a few words about vector search then. So here is the kind of issue in terms of representation learning, okay? Learn to represent objects with vector embeddings. Semantically similar objects are closer to each other. So I think since the development of ChatGPT, we've focused very much on text. I think because it was easy. More recently, you've seen the development of this kind of multimodal as opposed to multi-model, which I mentioned for SingleStore a few moments ago. So the idea is that we have, for example, here, some text, okay? Famous kind of phrase in the Western world, you know, the quick brown fox jumps over the lazy dog. And then through some kind of representation learning and encoder, we have the equivalent represented as a series of numbers here, an array of vectors. And similarly, you can see that we have an image, okay, here, okay, of exactly the same piece of information that we've just about, the fox is jumping over the dog. And again, through this kind of representation learning, we have a representation of that on the right-hand side here, okay, in terms of numeric values. And then last but not least, and again, if you attended yesterday, you'll know that I was doing a little bit of kind of voice text, speech to text, and using OpenAI's Whisper. So why not have it like this? You know, I actually speak the phrase, the quick brown fox jumps over the lazy dog. And similarly, through the whatever the representation learning mechanism is, we have a kind of representation of that. And that's exactly what I was doing yesterday. So we've got multiple ways of representing the same kind of essentially what is the same thing, whether it happens to be a visual or text or speech. We have a means to be able to represent that in a way that a machine could understand, for example, or a large language model could understand. So this is really the challenge, and this is what we're going to try and do today, to have the ability to represent some information or to try and solve a problem in a way where we can utilize these to do useful things for us, okay? And that's the basis of today's session. Okay, so vector search, what is it? Well, it is looking for this, the applications that we've seen in terms of retrieval, augmented generation, semantic search, text, face matching, object photo matching. I kind of alluded to that just a few moments ago. But the idea is that we have something that we can represent in a vector format. So here you can see the big purple dot in the middle here, okay? And then perhaps we're interested to find, using some appropriate distance metric, to say what are things that are kind of close to that, similar to that, that we might be interested in. And then we specify some kind of boundary. In this particular case, we're saying, all right, look for the ones that are the 5 closest to this, based upon some distance metric that we specify, whether that's dot product or Euclidean distance or cosine or whatever. And then we can see that within that circle, we have found these 5. So you can see that some of these are a bit closer than others. So here, for example, we've got something fairly close. There, we've got something a little bit further away. And so its distance metric value will be different. So we might order these in some way, okay? And find the one that's the best match, or the best 3, or the best 5, whatever, the top sort of K matches. And that's very, very useful for us in terms of doing useful work. All right, so here's an example using, get the top 5 closest matches to a query image. So interestingly, we are storing photographs, and this particular example is Emma Thompson. Okay, so in our system here, we have these files that we are referencing. Perhaps these could be stored directly within the database system or just on the file system somewhere, and just we reference these and provide a path, for example, in the actual table itself. And then using this thing here called FaceNet, for example, we have some appropriate value that is associated with that. And once we do this kind of dot product operation where we're looking for, this similarity, this distance metric, then we can find a score. And the higher the score, in this case, you can see it's 0.999999 and so on. That is the best match. Naturally, sometimes, you get rounding errors. But if you take a look at this, for example, if we were to compare this, which happens to be Emma Thompson 0001.jpg with Emma Thompson 0001.jpg, well, you'd probably expect the answer that, they are going to be a perfect match. And that gives you the highest score. Yeah. Using something like Euclidean distance, for example, if you were to do that and say, what's the distance between them, it will be 0, right? If it's identical, it's the same thing. Here we're using dot product. Okay, so there we go. It's the closest match using vector similarity. So in this particular case, we've got 2 different images, you can see. And so it's trying to use this as the source of the query. And then we're getting this back as the best match. So there are some characteristics there. And obviously, you can see that both of these are Emma Thompson, okay? So very, very useful. So where do vectors come from? Well, no surprises here. Large language models, okay, custom models, your internal AI or data science team, neural nets, for example, for face matching, neural nets for image matching. Okay, so a variety of sources that you can find them. And sometimes even these values can occur naturally. And by that, I mean, there is a data set that I used a little while ago, some months ago, from Zalando, which happens to be I think it's a 256-bit grayscale images of things like sandals, shoes, bags, T-shirts, these kind of things. And if you flatten that out, you get a vector of over 700 dimensions. And that is a kind of something that you don't have to encode. It already has a representation. And then straight away, you can just store that in the database and be able to run queries on that. And you can say, all right, I'm interested in T-shirts that look like this, for example, your query string, and it will go away and try to match and return whatever it finds in terms of, whatever distance metric you're using, things that are closest to that. And that's, again, very useful way. So these things can occur naturally sometimes, and that's absolutely fine. You don't have to use an encoder to be able to do that. There are specialized database, vector database vendors out there. Here's some just a list of some of them. The thing today, and I've been around in IT long enough, and I've seen these waves of database technology, come and sometimes go. So years ago, object-oriented databases, which was kind of my area of research when I was, doing sort of research work. And then, it's XML databases, NoSQL databases, and so on. There's a whole bunch of stuff in between them. Today, of course, vector databases is the flavor of the month. Whether you happen to be a pure vendor in terms of, very narrow focus, just supporting vectors, or you happen to be, say, a relational vendor. I mean, if you look at Postgres, for example, offering PG Vector, and other relational vendors doing that as well. I mentioned SingleStore support for that has been there some time. We've had that capability as well. You're spoiled for choice, okay? So there's lots of possibilities. But the key point here is it really depends in the end what you want to do. And if you purely want to focus on vectors and nothing else, maybe one of these products is suitable for you. And you want the kind of long-term memory, okay? You're storing stuff for the long term because you're going to query it again and again. That might make sense. However, typically in enterprise environments, you want to do more. You want to be able to query the data, do additional things with it, and you want the power of query languages that are already well supported. And things like SQL, for example, generally tend to get extended with some of these capabilities over time. It's already widely used anyway. Okay, so in the interest of time, okay, I won't dwell on this. We'll go on a little bit further. Alternatively, if you don't need the persistence, or you're not particularly interested in saving things, or you might say, well, okay, I can just write it to the file system. That might be fine. Depends on your requirements, obviously, but there are libraries that will allow you to do this as well. Okay, so there are some limitations as well to these. That might be fine for single user or a small group of users if you don't need the CRUD features: create, read, update, delete. You don't need the multi-user access, for example, that a database system gives you, and so on. Okay, so that's possible too. So a little bit about the history. So I've already talked about the fact that we introduced vectors in 2017 in the product. I've mentioned .product and Euclidean distance. And by the way, although SingleStore doesn't support cosine similarity natively, within the, I think it's about like less than 10 lines of code. Essentially, you can write a couple of functions in SQL that will allow you to do that. There are examples of that actually within the documentation. Okay, so that's perfectly possible to run that as well. Okay. In the past, with the support that originally came, it was exact KNN. Okay, there was no indexing, so whatever answers you got back, 100% accurate. So fully integrated with SQL, and it's great for millions, possibly sort of tens of millions, and give you very fast results back. Now, obviously, over time, because of the interest in ChatGPT in 2022, I mean, SingleStore decided, well, perhaps it's time to look at this again. So added a dedicated vector type, for example, earlier this year, as well as approximate nearest neighbor indexing. And now you could potentially store hundreds of millions, billions, even if you want up to trillions, if you've got data that large. And you can create an index, probably going to be very large, but you could do it, with an ANN. And so the benefit that you get there is that you get the speed in terms of the results being returned very quickly because of the index. However, you lose the accuracy. So if you're prepared to forego, and it's a balancing act, if you are happy with, say, 95% accuracy or more, 96 or whatever, 97, and that is sufficient for your business needs, you could get the answers back in milliseconds, okay? Microseconds, very, very small amounts of time, depending on how large your query is, okay? The index will do the hard work for you. You get the results back quickly, and that could be critical to you in your decision making. So you decide, okay, what's the most appropriate thing, and weigh up the pros and cons of this, whether you are happy to forego some level of accuracy. And by the way, this is not unique to SingleStore. I mean, that's just the way that ANN works. That's why it's called approximate nearest neighbor. Okay. So why use SingleStore for vector search? Scale out architecture. Okay, we are a shared nothing distributed SQL database, support SQL. Okay, transactions I've mentioned, analytics I've mentioned, vector and text search. Okay, I've mentioned, and this is the key thing. Okay, this is the major selling point, all in one place. Okay, a single product that will do all of this for you. Just for your information, one of my colleagues, Eric Hansen, who's a director at SingleStore, I think he will be presenting a paper at VLDB. I believe that's in Guangzhou in China. Anytime. I think the conference is scheduled for the end of this month. So I believe Eric will be presenting a paper on this. So we've done some performance as well, working with the Purdue database group, university. So doing some comparisons between SingleStore and some of these other technologies. So here it's using a PG vector, for example. And in this particular case, SingleStore came out between 47 and 100 times faster. Okay. And this one is taking a popular open source pure vector database. There's PG vector and there's SingleStore. Okay. So these results are more in detail in the research paper, okay, which I'm sure we would have permission to share as well subsequently. So in the world of database systems, there are three really prestigious conferences: VLDB, ACM SIGMOD, and IEEE Data Engineering. And so Eric will be presenting this work at VLDB. Some of the customers, in case you're wondering, is anyone actually using this technology? Well, we have over 45 of the 350 plus customers that we have globally that are actually using vectors within the product itself. Okay, and there's just a small sample of some of the customers that are doing it. Okay. All right, so the dedicated vector type then. So you'll see this momentarily. Okay, once we start doing the hands-on, essentially you just specify the column name, okay, and the fact that it's of type vector, okay, the number of dimensions here, and by default it'll be 32-bit floating point. Like I said before, you can change that if you wish. So if you leave this out, for example, if you don't specify that, it defaults to this, okay? It assumes that it's 32-bit anyway, okay? An FYI, there is no limit to this. You are not restricted to this. Now, in theory, obviously, storage will run out at some point in time, but SingleStore doesn't impose a limitation on that. Now, realistically, once you start creating several thousand dimensions, you really need to think about, is this the right way to do it? I seriously doubt whether you'll need, in the tens of thousands of dimensions. I cannot see a use case why you would do that. If you use OpenAI or any of these LLMs, this 1536 is a number that should be very familiar to you, so you'll know exactly where that comes from. Okay, and so previously we used to do the blob type, which was less flexible. Okay, yeah, do the vectors without problem, but the new vector type provides some real benefits. Okay, and we'll use that today. And again, there is support for a couple of these operators. So rather than having to type out the word ._product or Euclidean _ distance as the function names, it's possible to use these kind of infix, this notation, okay, which we'll be doing today. Okay, and more about that a little bit later on. So here's an example of sort of an embedding here, if you like. You can see that we can do it this way. Okay, and here's the kind of create table statement. So in this particular case, we are using 4 dimensions, and then so here are the 4 dimensions that we are storing in here, along with an ID column at the beginning here, of which we are inserting a value 1 for this particular case. Okay, very, very straightforward. And then, as I said before, lots of distance metrics available. SingleStore supports these 2 out of the box, .product and Euclidean. Cosine you can code up. There are others. We have customers, for example, have asked about some of these other methods. I think this one came up recently. And so there, essentially, what you can do, if that's something that you want to use and the product doesn't currently support it, you could write the code yourself if you want to do so. And one way to do that is using WebAssembly. So I believe the customer that was interested in that actually went ahead and is implementing that in WebAssembly, okay? So that's something we talked about yesterday. So that is a way to extend the capabilities of the core engine, if you like, with things that it doesn't currently support. All right, so we've talked about this, okay? So this is again, the infix notation for .product and for Euclidean distance. I believe this comes from the way that the Postgres uses its infix notation as well. Okay, so we'll look at that. All right, now let's move on to recommender systems then. So give you a little bit of a background there, and let's talk about what is the issue here. So a couple of different types of systems that we can work with. Okay, implicit rating systems. Okay, use actions like clicks or view times to infer user preferences. I'm sure you visit lots of e-commerce sites. You browse around. You look at different products. The vendor is keeping a history of what you are looking at, and then as a result of what how much time you are spending looking at things or what things you tend to look at, they might recommend other things that they think are of interest to you. I get this all the time. There are explicit rating systems, okay, rely on direct user input, such as star ratings or reviews. That is what we are going to use today, okay? So the data that we have are explicit ratings for movies, for example, okay, between 1 and 5. Content-based systems recommend items similar to those user has liked before, using item features like keywords or genres. So in Notebook 6 today, you'll see that we are able to utilize full text search as well, because we have genre information, but we're not using that as part of the initial kind of process of model building, but we are able to utilize that later if that's something we want to filter on. So we can create a full text index on that and utilize the capabilities of that to help us narrow down the results if we wish to do so, okay? But again, that's optional. And as you can see, lots of other types of recommender systems too. So collaborative filtering, for example, users with similar tastes and recommends items like those, similar users, hybrid recommender systems, knowledge-based recommender systems, context-aware recommender systems. It's just a sentence or two about each of those. Essentially, there's lots of possibilities, lots of choices there, okay? Again, in the interest of time, we'll move on a little bit, okay? All right, so the thing that we're going to try to solve today is this so-called Netflix problem, right? How to provide personalized recommendations, okay? For movies or TV show recommendations based on user viewing history and preferences, and particular ratings that they've given to existing movies that they've watched. There is also this challenge. I mean, if you think about Netflix, for example, a very large sort of scale data processing that they have to do in terms of managing all of the user interactions that go on, the history rate, the ratings, searches that people do, and so on, and maintaining all of that information. Quite a huge challenge of a problem. The diverse content as well, wide variety of content types, genres, user preferences. What about algorithms? Okay, to develop sophisticated collaborative filtering, content-based filtering to improve accuracy. This is something that I think they're always looking for. And by the way, not just unique to Netflix, but we'll focus on that very much today. And scale. I mean, it is a very large global company, and you can imagine in terms of the number of users that they have, ensuring that their recommendation system can scale to meet the needs of all of their users. And no point in having to wait a long time for your results. You want instant real-time processing to give real-time recommendations. You want to capture the user's attention straight away. Okay, offer them something that you think is going to be of interest to them. And here's a good one, this cold start problem, okay? So this thing that, what happens if I'm not a Netflix user? And by the way, I'm not, okay? So if I wanted to sign up, Netflix has absolutely no information about me. I have never watched any movie before, and then how to recommend to me certain movies, okay? Maybe they ask me a set of questions, what sort of things you like watching, what are your preferences, what genres, how old are you, for example? That might have a bearing. So I happen to, just out of interest, I'm a great fan of all these Bogart films, okay? It's Casablanca and so on, I like the black and white stuff, going back in time. So that might be something that they get to know, and maybe as a result of that, they can recommend some movies for me for that, okay? But other things as well, this A/B testing, okay, to continue to experiment with and evaluate different recommendation approaches, improve performance. User privacy, very important, okay, that we protect the users, the need for personalized recommendations with privacy, data protection concerns as well, very, very important today. All too often we see these kind of data leaks going on. I just heard of another one just recently, and it's kind of shocking, okay, but that's life. Unfortunately, these sometimes the bad guys are far more clever than the rest of us. And then engagement metrics, okay, for measuring and optimizing user engagement metrics such as watch time, satisfaction, retention. So lots of things, as you can see, to think about. And we can focus very much around the movie kind of problem today, if you like. But if you think about it, all of these concerns, all of these issues would be relevant to a wide range of other domains as well, regardless, we're not simply limiting this to just movies. Okay, so in a sense, if we boil it down to something like this, we can create this kind of matrix, this kind of almost like a spreadsheet, if you see, and we've got users along here, and we've got movies along here, okay? And then it just so happens that in this particular case, we can see that this movie has received a rating from this particular user. So has this one. But this user has not watched this movie. So we don't know what they might really rate this as. And so one of the challenges and one of the issues that we're going to look at today is kind of trying to fill in the gaps, if you like, predict what this might be. And similarly here, you can see there are gaps elsewhere as well. Now, at one level, okay, so these are very specific. This is, providing a value between 1 and 5, where 1 is and 5 is awesome, okay? And typically, I think for the data set we're going to look at, a lot of ratings are between sort of 4 and 5. We see movies are very popular there. But again, it's, how can we represent this in a format that we can convey and store and then be able to do useful work with? So go back to that slide that I showed you right at the beginning in terms of, having appropriate encoders, having a means of taking some information and being able to represent that in a format, vectors, which will be useful to us then, because then we can, work with those, we can query those, we can run these kind of distance metrics on those, do, this kind of factorization, multiplication, all sorts of interesting things that we could do with the data. So that's really the challenge that we're trying to solve. Now, today, I am by no means a machine learning expert. I have simply taken one approach. If you are an ML expert, awesome. Have a look at the solution. I'm sure you can improve upon it. And then remember that this is just the kind of like the first iteration, okay? It's like tackling the problem and saying, okay, let's take a set of decisions. We'll do it and we'll look at the results. It's not bad. Let's see what sort of answers we get back from that. And then it's iterative, If we want to improve the quality, we go back. We look at the model. We see what we can tune. What can we change? And then let me give you an analogy. So, my wife and I, we recently went down to Brighton, and I live in London, okay? So it's on the south coast, and we decided to have a day out at the seaside. And we're driving along on the motorway, and, we open the windows, and the car is actually coming up with a warning sign saying there's drag. There's a drag effect. Please close the windows, right? It's affecting the performance of the car. And so, you close the windows, performance of the car should improve. Okay, it may be marginal, might be a tiny bit, okay? But we see some improvement in terms of how the car performs overall, its petrol consumption, and so on. And so typically within this model building process, there will be things that we can change, some parameters here and there. We can fine tune them, we can adjust them. We can see what impact that has upon the ultimate model. And then there are a set of metrics that we can use to assess the quality of the model as well. How good is it? So we'll do a little bit of that as well. Okay, so let me just go through this and then we'll get stuck in and get you started with the code. Okay, so please sign up if you haven't already done so. Okay, very simple. The link that he's provided for you in the chat. Workspaces, not too much to say about that today. Okay, but essentially we will be using that momentarily, and we'll be creating some, if you've got the shared tier, the database is already created for you, okay? And hopefully all of you have decided to opt for that option simply because it's super simple to do. But if you need more capability, go for the standard tier, and it gives you a lot more flexibility. So in this diagram here, for example, you could see this kind of shared nothing architecture. You can see the storage as well, the separation of storage and compute. You have these aggregated nodes, leaf nodes. You really don't need to know this detail, okay? It's unnecessary, but essentially, being a scale-out distributed SQL database, one of the challenges, as we mentioned with Netflix, for example, is this need to scale. And so if you have a problem where your data is very large and you want the ability to scale out and utilize the full capabilities of a distributed database system, that is one of the considerations that you need to think about. We don't need to do any of this today, okay, because we'll be focusing very much on the Jupyter Notebook environment, which will look something like this, okay? So we'll get you started on that in just a moment. Okay, and there we go. So let me stop at that point in time now. Let's get you set up, okay? And then let's start working through the notebooks and running the code and see what sort of output we get. All right, so let me switch over here. So as I said before, hopefully you've all created your accounts, the link that Yukti has provided. And as I said before, if you are creating a brand new account, then by default, you'll get the this starter workspace, which I have here. Okay, and they've even graciously given me a database there. So that's all done. If you've downloaded the zip file, which again, you can share the link with you, the GitHub repo. Like I said before, I suggest you go for the code option here. Just select the zip file as the option. Okay, it's less than 30 megabytes. I think 25, 30 megabytes. The reason it's a little bit larger is because of the PDF files, okay? So if it was just the IPython notebooks, it would be a lot smaller. But that's for safety, okay, in case we have problems. But there we go. All right, now, how to get the notebooks in. So if you've unpacked the zip file, the thing is that, okay, you've got some compute resources, you've got a database system, how do you get the notebooks into the environment? So the way to do this is if you look on the left nav here, this thing, okay, Data Studio. All right, so you click on this, and there we go. On the right-hand side, you see this big purple box where it says New Notebook. If you click on that, one of the options here is Import from File, okay? So all you need to do is just select that, and essentially the wizard either just browse, okay, or drag your IPython notebook one by one. Okay, unfortunately, you can't put all 6 in here at one go, but you know, you can do it as we move along. So do the first one, okay, which is number 1, which is there, and then again you have the option of where you want to put it, whether it's personal or shared. I just stick to personal, will be fine. And then once you've done that, this purple box here will activate. Okay, currently you can see it's got nothing there. I've already got these notebooks in my environment. And then you just need to repeat this, as I said before. Get the notebooks in one by one. And what you'll find is here we have the notebooks. Okay, so this is number 1. Number 2, oh, sorry, number 3 is slightly out of order here. I think this is the way I loaded them in. Number 2, there we go. Number 3, number 4, there we are, and 5 and 6. I mean, if you wish, you can leave 5 and 6. Okay, like I said, they're optional. Not important for today. We've, you know, under time pressure, we won't have the opportunity to get through everything today. But once you've done that, okay, you have the notebooks here, and then just click on this first one. And the key thing to ensure here is at the top here that it has your workspace and the database selected here. Now, because this is a brand new account and I've got nothing else running here, you'll see the only option it gives me is the starter workspace, which it automatically created for me, and the database, which again, it automatically created for me. That's absolutely fine, okay? We are seeing that same error, unfortunately, that we were seeing yesterday. So I'm a little bit concerned about that, but we'll see how it goes. Like I said before, we have the PDF files in the event that we find there's some network connectivity issues. We can work through that. That's absolutely fine, okay? You can do this in your own time. All right. So if we take a look at this then, okay, so notebook 1. So essentially all that we do here is we just check to see, are we using the shared tier? If so, no need to create any database. If we are not using the shared tier, then we do need somewhere, a repository, somewhere to add. And in that case, what this will do is it will create a database called RecommenderDB. Okay, so if it already exists, it will drop it, and then this one will just create it. Okay, so let me just position this, and I'll just do Shift Enter. Okay, we'll try this. Now, it shouldn't take that long. So my concern is that error message that popped up that you saw a moment ago. Okay, you see here previously, this took 19 milliseconds here. And now it's taking a lot longer than that. So I'm a little bit worried about that. Let me just stop this a moment, right? Not even letting me stop. Just refresh the page. Let me try that. See if that helps. Okay, so just reload that. Just try this again. And at the top here, oh, there we go. Same issues there, unfortunately. Can't connect to my SQL Server on name or service not known. Let me take a screenshot of this, okay? This is something I need to pass on to engineering. So hopefully, okay, let me just try one more time, okay? Let's see if we can do this. Just make sure these are selected. And if not, I'll just stop for a moment, just pass that screenshot on to engineering, see if they can fix that for us. If not, it's going to cause a problem. You can see here that this clock is still running. So somehow it still thinks that... let me just try and run this again. And it doesn't like that. No. Okay, let me stop that. Okay, let me try and read. Ah, good. At least we got something back. Right, let's just try this again. Let's see if we can do this. Yeah, Yuxi, could you do me a favor? Could you please check the questions in the Q&A just to
Right.
see if other colleagues, attendees are having similar problems in terms of...
Yes, that's I was about to point it out. Like I
Okay.
have a yeah, we have a comment from Abhishek, Gautam. They are
Yeah.
also getting the same error.
Okay. All right. Let's
Chandra
just
is
give it
also
one
getting the
more
same.
go then, okay? And we'll just take a timeout just for 2 minutes, okay? Whilst I post that message to the appropriate internal Slack channel to see if they can address this issue. If not, let's switch to the PDF files, okay? As I said, it's a backup. It's a shame, and I'm sorry about that, but we need to progress and we need to get through the to the material. So let me just try one more time here. Okay, and then just try and see if we can just refresh this. All right, and the important thing is to ensure that this is currently ghosted out, as you can see, so it's not actually connecting here. It's trying to connect to the kernel. We're not getting... okay, so I think that's not going to play well. All right, one final time. Let me just refresh again and see if we can get something here. All right, so I tell you what, we're getting something here. It looks like this has come back. It's not ghosted out anymore, and so it's connected. Okay, like I said, I've only got one workspace, and I only have one database here. So in terms of choice, it's only going to connect to the one, and that's it. All right, let me try one more time here, okay, and see if we can do this. Voila, it seems to be working. Awesome. There we go. So it came back very, very quickly. You can see in 21 milliseconds, simply because it was able to detect that, yep, this is a shared tier. I don't need to create a database. Just skip that step. And as you can see, it's just gone on to the next step there. All right. And again, if you're having difficulty, just get through this, okay? And then again, Yuxi, please check to see if people are still having difficulty. If so, please continue posting, okay? Let's collect this
So
feedback.
seems like it's working. Seems like
Oh,
it's
okay,
working.
awesome, great.
Yeah.
Again, my apologies, okay? So we will feed this back to engineering, okay? So that they can look into these issues, these connection issues, which really delay the progress. But anyway, let's move on, okay? So the next step we need to do is we need to create a couple of tables, okay? So we're going to create 3 tables. And at the beginning here, we make sure that if these tables already exist, we just remove them, okay? For one for users, one for movies, and one for ratings, okay? So you'll notice here that we're going to store some vector data, and it's going to be in this column here called factors, okay? and it's going to be 100 dimensions in size. Okay, so you can see the actual vector type there that I mentioned previously, right? This is the new way to represent vectors. And by default, it's going to assume it's 32-bit floating point. Okay, again, I could change that if I want to. The rest of these are fairly standard types. Okay, so this is the users table. There's the movies table. Okay, and there also you can see we've got this factors column there for vectors. Again, similarly, 100 dimensions. Now, why choose 100 dimensions? Well, this has something to do with the model that we're going to build. Okay, potentially you could change that. Okay, but let's give it a default to begin with. And then we've got this ratings table. This is essentially the data that we use in order to build the machine learning model. So it has, and we're going to use something called SVD. Okay, we'll get to that shortly. So this has got the users. So remember that diagram I showed you. Let's just go back here a moment. Just get rid of this. Okay, this thing that I showed you here. So essentially, we've got a table of users. We've got a table with the movie data, and we have a table that combines these two columns plus the ratings that we have, okay? These things. And this is important because remember, this is explicit. So that's what we're using, and we need to store that data as well, right? So let me just run this. There we go. Oh, connectivity problems again. It's just, now, was this successful or not? It seems to suggest it is. So if we look at this, it says 327 milliseconds. Now, it's added a new cell at the bottom, and by default, I think it's here, you can see it's SQL. So you can change that to Python or Markdown as well. And so in here, why don't we just check to see what tables are available? Show tables. Let me run that. And fortunately, these seem to have been created okay. Okay. Now there's something here called movies backup as well. I ran this a little bit early on. You won't have that. Don't worry about that. But the ratings and the users. So all of these seem to be created. Great. So that's done. Okay. So this is our first task, is just to create the database and the means to store the information that we want to get in. And so I'll close this now and load in the next notebook, okay, which would be number 2. And again, give that a moment or two. It needs to connect to the kernel here, okay, the resources that we are running. Currently, it's kind of ghosted out, as you can see. We need that to be dark. And if it's not playing well, I'll just try and refresh this again. Okay, there we go. See if we can get that. So it's certainly loaded fine. Okay, let's keep an eye on the time. Okay, we are almost at the top of the hour. All right, give that a moment. All right, I mean, it's not going to play well with us. That's okay, no worries. Let's just scroll down, okay? Let's take a look at what this does for us. So let me walk through this, okay? Whilst we see that the connection may come through there. Sorry about that. So first thing we do here is some standard Python stuff, okay? And again, let me just see if I can just make the zoom in a little bit further, make this a bit bigger. So we just clear the cache, okay? Just useful to do sometimes in terms of the environment. Otherwise, you find sort of versions of libraries hanging around. And then we just install matplotlib and word cloud, okay? So we're going to do a little bit of graphics, okay? Some charts and things. We're going to look at the data. We'll do the import, a couple of libraries there, okay? Requests, zip file, URL lib, for example, because we're going to get some data from outside. And then the next thing here is we'll just walk through and essentially download a couple of zip files. And there's 2 locations that we get this from. One is from the group lens group, okay? It's the research group. This is the large 1 million movie data set. And then this separate one here is from GitHub. Okay, this is from Babu Thomas, who very graciously, he scraped the internet. He looked for posters that represent these, the movies that are part of that data set, and he's put them on an S3 bucket somewhere. With this particular zip file, essentially what we have is the URL that points to the poster file. And it's kind of not very large, okay? It's a small one, but it's very nice if we want to do a little bit of visualization, okay? It's kind of nice to be able to see that. There are backup of these on my GitHub repo in case you have difficulty downloading them, just replace them with the appropriate lines there, okay? And then essentially what we're doing is just downloading those. We're specifying 2 locations where we want to extract these into the posters and the datasets folders here. And then literally we just download and unpack those files. And there you can see the message just below there. It says it's done the movie lens, downloaded, unpacked successfully to posters. Okay, so that was the Babu Thomas. And then this one here from the group lens group into the datasets. That dataset has got a couple of files, okay, as well as a README file and some other information as well. So that's done that all for us. Okay. Next thing to do then is simply read the movie data in. So we're just going to use pandas to do this. Just create a data frame. Okay, so we just import pandas as PD. Okay, and because the data are sort of fairly, the format is kind of, yes, it's being read in as a CSV here, but it's not actually using a comma as the separator. It's actually using these kind of 2 colons together, pair of colons as a sort of field separator. So what we're simply doing is, yes, we're doing the PD read CSV, but we need to provide a little bit of information to it to say, well, okay, here's the location for the for this DAT file, okay, which is the movie information. So we're just creating a movies data frame here. This is Python that we're using. The separator happens to be this. There are no headers in this file. We're going to use Latin 1 encoding, okay, just for a bit of safety there. And by the way, we'll add these columns to the data. It's going to be called ID, title, and genres, okay? And if we take a look at that, just look at the head, we can see here that, it's got the unique identifier here for this. It's got the title of the movie here. Okay, in this case, it happens to be Toy Story, for example, Jumanji, Grumpier Old Men, Waiting to Exhale, Father of the Bride 2. And then we can see that the genres here are separated by a vertical bar. You can see there some examples. By the way, this seems to have returned. So you're welcome to run those. I think in the interest of time, there you go. It's not looking very healthy there. So I'll avoid that just to waste time. We're wasting time if we go back and do that. Well, let's just walk it through. All the results are out there for you. Okay, so we can just talk through it. All right. So it would be nice to get a little bit of sort of an assessment of this, not just looking at this information like this format, but why don't we create a word cloud? Look at sort of the common words that occur within that, okay? And that's exactly what we're doing there. This is why we did the import a little bit earlier for Matplotlib and word cloud. And so here you can see we've created a word cloud. No big surprises there. What are the common things? Boy, girl, man, woman, love, standard sort of stuff, things that, and the larger it is, the more common it tends to be. And this is kind of interesting. You see this thing, it's movies, but it's the original one. Then, of course, you've got a second one and a third one and a fourth one and so on. So that seems to be fairly common. That just gives us a little bit of a sense in terms of, all of the words that appear very commonly across all of this in terms of these. Let's have a look. What are we looking at here? It's the titles, right? Not the genres. Okay, remember, it's the titles that we are plotting here in the word cloud. Okay, so that's done. Our next challenge then is to say, well, okay, let's read in the poster data as well. because what we can do then is find the appropriate poster for that movie, given that we know the movie name, we happen to know its genre. Why don't we read in the poster data, which is in a separate, which is actually in a CSV file, but we provide a little bit of information to it. Again, there's no header, and then we're going to assign a couple of headers to it, ID and poster. And so if we read that in here, you can see that indeed this is a map between this ID and the ID for the movie just above. And then there you can see the URL, which is stored somewhere on an S3 bucket, which is, I think it's a JPG file. And that it contains the poster for that. Now, not every single movie has a poster. We'll deal with that in just a moment. Also, sometimes you'll find that when you're running this, occasionally some of these URLs, the image is no longer available. It's broken. Unfortunately, I wasn't able to accommodate that, but certainly for the situation where there's no poster available for a movie, we can deal with that. We'll see how to do that in a moment. And then so all we do here is we simply merge posters with movies. Okay, so combine the two. It's a bit like a join, okay, across two tables, but we're just taking the two data frames, and that's what we're doing here. Okay. And we're storing it in the movies data frame. And then here is the kind of the way to deal with the fact that if we cannot have a particular, there is no poster associated with a movie, here's what we're going to do. We're going to substitute it with this one, placehold.co. It's a 100 by 150 JPG, okay? And then just fill any blanks there with that, in the case that we find that after the merge, a movie does not have a poster. And if we take a look at this, then we can see now that here's the combined data frame. Okay, so we've got the ID of the movie. There's the title that we saw, the genre, all of that's the same. And here we've merged in the poster details on the right-hand side there, okay? For this one, for this particular 5 examples that we're looking at, there's no missing values, so that's fine, but there will be some of these that are not available. Next, we just read the user data in. Okay, so this, again, because it's a DAT file rather than a CSV file, we have to deal with this in a little bit sort of special way. So again, provide the location, same thing as we did with movie data. Tell this that we're using Python, that it's got this separator. There are no headers. That again, Latin 1. And then here, just providing the column names, ID, gender, age, occupation ID, zip code. And again, we can take a look at the head. So here's the information here. Now, if you're sharp-eyed, you'll see, well, hang on a minute. If I look at the first row, okay, and if I look at the, I've kind of overwritten it. Let's take a look. The age column, that looks very surprising. How can you have somebody that's 1 year old? All right, that looks a bit strange. And the thing is that value represents a range. Okay, it is not literally a 1 year old person or child, as the case may be. Probably if they're rating movies, that would be very worrying as well. But that represents a range. Okay, it's just a single numeric value to represent a range. I forget what the range is, but it's in the README file. And then similarly for the others as well. Okay, so this is slightly older range, as you can see there. This is slightly younger, and so on. Okay, so this is what this represents. It's not literally that value, but represents a specific range of ages. And then again, we can see the gender in terms of whether they're male or female, the zip code. Now, why use this information? Because ultimately, I mean, in this case, we're not utilizing this, but this could have a bearing. For example, we may find that there are taste differences between men and women. It may depend also where you live. You know, if you are perhaps somewhat more affluent, perhaps your tastes are different from someone who is less affluent. You know, I'm just guessing, okay? Just some possibilities. So the zip code itself could be an indication, again, in terms of being a means to target particular customers because they know you know they happen to live in this part of the city, and therefore there may be certain movies that, and they may be more interested in others. Again, it's a challenge, okay? And then finally, here we can do a little bit of analysis to see what's the split between the data set in terms of how many men and women there are. Well, we can see that men outnumber women significantly there. You can see that it's, what's that, 2-to-1, 3-to-1, something like that. So again, in terms of building the model, ultimately, that might be something that you might want to think about in terms of what sort of movies you want to target to particular genders, for example. There used to be the old saying, and I think this is incorrect, but many years ago, the adage was that, you know, girls tend to play with dolls and boys tend to play with the toy cars and trucks and things like that. That is not true. Okay. Maybe it was true at one time, or perhaps, you know, historically that was the way things were. Or, you know, girls like pink and boys like blue. No, I don't think that really applies. But you know, there may be things that we detect, other sources of data that we may have that may have a bearing in terms of gender. That could be a significant thing that indicates, you know, what sort of movies to target a particular group of people. We have some information about occupations as well. Again, this could be very important. Now, this information is provided separately. It's not actually available in a CSV file or a DAT file. It's something we have to code up ourselves here, which I've done for you. And you can see there are 20 different categories, okay, whether they're academics, they're artists. Even here, we've got a category for farmer, for example, okay, K-12 student, lawyer, and so on, whether they're retired. Okay, so what we simply do then is just to create this, and we take the opportunity then to, again, build a small data frame here just for the occupations based upon that data set. Here we've just output that. That's what we've done. And then we merge this with the users. So you saw a little bit earlier in terms of occupation, and we again do a join across these two tables. And then once we've done that, you can see here that now we've got, in addition to the ID, the gender, the age, and the zip code, we now have a little bit of information about what that particular user is. We don't know their name. We only, I mean, zip code is kind of fairly general, just a postal code, but we have a bit more information about where they come from in terms of the kind of things that they do, the job or the role that they have. That, again, may have some bearing in terms of the model. So here we can do a count as well to see, you know, how many people are within each of these different groups. And we can see that far and away, the largest group is college and grad students, nearly 760 of them, and so on down until we've got the smallest group at the bottom there. There are only 17 farmers there. Okay, so just some analysis of the data. And then our final task here is to read the actual ratings data, the bit that will help us in terms of the model creation. So similar sort of process that we adopt. We extract, we've specified that it's Python. Okay, the separator, two vertical, you know, two colons next to each other, and so on. Okay, and then we provide the details of the actual, you know, user ID, movie ID, rating, and the timestamp here for when that was done. Okay, and if we take a look at that data, we can see here. So this is really the important bit of information for us. And typically for recommender systems, in this particular case, we are using movie. Okay. But it will be something like user, and it will be something like item, and there will be some specific rating attached to that. The timestamp is irrelevant in this case. We don't really need it. Doesn't have a particular bearing that I think on our model building, but there we go. And so here, again, we can do a little bit of analysis of this to take a look at the distribution. I don't know how useful this is. I mean, it's giving us standard deviation, minimum and maximum, and so on. But I guess it's helpful to kind of understand that, you know, I believe there's no missing data here, for example. So that's very useful. Okay. And then one of the things that we can do then is to actually look at the distribution of the ratings themselves. You know, how is this done? Let's make this a bit smaller. I think let's just try to get this Zoom out. Okay, make that a bit smaller so you can fill the screen here. So you can see, as I mentioned a little bit earlier on, the vast majority of ratings for movies are sort of 4 and 5. 3 comes up strong as well. As you can see, well, actually 3, 4, and 5, I think is fair to say. 3 and 4, followed by 5. And then most people don't seem to rate movies too lowly. Okay, 1 and 2, I mean, 1 is like not very good at all. 2 is okay, only marginally better. But that's, again, just a bit of analysis in terms of the data. And so the purpose of this is really what you would do typically as a data scientist, read the data in, take the opportunity to examine it a little bit, do some analytics on it, take a look at the distributions, take a look, and it might give you some ideas and some thoughts in terms of what are the sorts of things that you might be interested in, what you could apply later, and what you could tweak and tune subsequently in terms of the data itself. So that's really the purpose of that, to help you. And so finally, our goal then is to say, well, okay, we've got everything in the appropriate format in terms of the data frames. We've done the joins. We've got everything merged. We've now got the data in a format that's usable for us to go forward. And so what we'll do now is we'll take these 3 sets of data, the movies, the users, and the ratings, and we'll write these out as CSV files to these appropriate directories, okay, minus the index, okay, because you don't want that. And now in the next notebook, what we're able to do is we can read this data indirectly, and subsequently, once we've got the information we need, we can write that directly to SingleStore as well, in terms of being able to run various operations across that. Okay, great. So now it's telling me start new server. Okay, well, let's fingers crossed, let me do that. And so let me just now load in the next one then. Okay, so 3. So how are we doing for time? Not too bad. It's just gone a little bit 7:15 my time. So currently it seems to be happy here. You can see that seems to be fine. Again, I'll just walk through this, okay? Because I think if we get bogged down, we'll just get stuck here. You're very welcome to run this if you wish as we go along, or just follow along as you wish. I mean, whatever is convenient for you. So again, same thing here. So in this one, this is the 3rd notebook. So again, just clear the cache before we start. It's helpful sometimes. We need matplotlib. We're going to use scikit-learn, and we're going to use Seaborn. Okay, so we're going to do a little bit of plotting as well. One thing that we're going to use is this thing called surprise. Okay, and this, let me just show you here, is this library here. Okay, so it's on the web. And this has got plenty of examples that you can use, as well as various built-in data sets as well. So this is very helpful reading. Again, you can do a bit of research, take a look at this. It's pretty good documentation, but that's what we're going to use. And so in this environment, because of the way that this needs to be installed, we have to run this conda install in order to do that. And that does take a little bit of time sometimes. You can see here, I did this a little bit earlier today. So that took about a minute to install that. But if you look down here, you can see that it actually has to get quite a lot of packages and then be able to put them in the right place as well. And we need all of this for this to run correctly. Otherwise, the environment kind of prevents you from installing this properly if you're just going to use a kind of pip install. So that's the reason for that. Okay, but once that's done, it's usable, fully available in the environment, and we can execute it. Okay, so our next task then is to just again, because it's now a separate notebook. Remember the last notebook we wrote out the CSV files? Well, we just need to read those back in again. So again, just point to the appropriate directories, and then we just get these 3 files read in again into these same 3 data frames. Right, so it's you could, in theory, I suppose, combine these notebooks together. You might say to yourself, well, why didn't you, just do that? Well, I think it's nice to be able to separate these steps as part of the workflow. So number 1 was simply about creating the tables. Number 2 is just reading the data, doing some analysis, cleaning it up, writing it out in a format that we can use. Number 3 is now reading that cleaned format and the clean data, and then just building our model. And so what we're going to use something here is called singular value decomposition, okay, SVD. So as it says there, so this notebook has got fairly extensive documentation in it, simply because I think the rest is very understandable and fairly easy to follow. This one, if you're not familiar with machine learning, will give you a bit more information about what we are actually trying to do. And so, as it says there, it's a mathematical technique used in various applications, including recommendation systems, and it's used for this matrix factorization, okay, which helps in predicting missing values in user item rating matrix. So exactly the problem that we have is in terms of what you saw in the slide deck a little bit earlier. Okay, so now we just, first thing we do then is to say, well, okay, the thing that we have, the bit of data that we know, we've got the user ID, okay, the movie ID, the rating. These are the 3 bits of information that we require. And from this, then we can say, all right, let's create a train test split. Okay, so we'll use a proportion of the data to train our model. And then once we've trained it, we're going to use the test data to actually test it. You know, how well can it predict based upon things that it hasn't seen before, right? So the training data is what's visible to it, and it will use that as a means to build a model. But then the test data is something it hasn't seen before, and we can use that to just ascertain, is our model any good, right? If not, we could go back, iterate, look at other things, and try a few other sort of mechanisms. So 30% of the data is going to be used for testing. And again, just set the random state, okay, so that whenever you run this, the results will be predictable and deterministic, okay? So as far as possible, okay? So you have the opportunity to run this again and again and again, starting from the same random state, and then the results should be the same. We've got a set of parameters that we are going to use. So remember, right at the beginning in notebook 1, you saw the value 100. Well, this is where that value comes from, okay? So this is the set of factors, if you like. It is that representation, the vector that is, derived as part of the model that we build to represent this information here, okay? So we've got one that represents the users and another one that represents the movies, okay? So that's why you saw in both tables, we had something called factors, which is a vector of size 100. And that's where this comes from, okay? Now, how do I know that this is a good set of values? And again, there's an explanation a little bit further down of what these actually mean, okay? I've taken the opportunity. There is this concept of hyperparameter tuning, okay? So you take some starting position, and you say, okay, I'm going to set a certain number of variables, okay? And I'm going to set them to these values. But I'm not sure, are these any good? Is this the best that I could achieve? There is a balance again in terms of how long do you want to do this process of going and iterating across the sort of wide range of values that you may have to find the best set of parameters that you can. Ultimately, compute time, you could spend an enormous amount of time doing that and spending lots of resources as well in terms of figuring out. So in this particular case, what I've done for you just below here is I've actually run this for you, and I've arrived at these parameters here, okay? Which I found to be fairly reasonable to provide the best kind of overall results. And how do I assess the overall results? It's using a couple of metrics here. This root mean square error, okay? And this root absolute error. Again, bit of an explanation further down for that, okay? Don't worry too much. But here we can see an explanation of what this n factors is, okay? So this is these kind of latent factors in the model. This is the underlying patterns or features in the data. So we've set this at a value of 100. You could increase this, make it bigger, okay? And it might be useful, but there is this kind of danger which you get in machine learning of overfitting. Essentially, you build something so unique to the particular data set you've got that you cannot generalize from that, okay? It becomes harder. I might build something that's awesome for this particular data set, but how would it deal with things that it hadn't seen before, or how would it deal with other types of data? And so there is, again, a trade-off there in terms of arriving at something that gives you good enough results and predictions versus something that might be so specific to you that you cannot generalize from that. And so just below here, you see that this comment here is coded out. If you were to run this, I think this takes approximately 30 to 40 minutes to run to arrive at that set of factors. And you can see that I've already set this kind of grid to a series of values, which it iterates over to find what is the best combination of these. And the best combination, certainly as far as those values are concerned, is this one here. Okay. This set of numbers minimizes this thing here. Again, this is an explanation of what this is further down. Standard techniques in machine learning. Okay. And by the way, in a Mac environment, if you want to uncomment this and you want to try this yourself, by all means, go ahead. Okay. But beware, it will take something like 30 to 40 minutes, I think, to actually execute and run. So you're welcome to test this out and add additional values here, if you wish, into these arrays. Okay, and try it out for yourself. So in this environment is Jupyter. I think if you just say, let's have a look. If I were to say, select all. Okay, so I've done the Command A here, and I think it's Command /. If I do that, you can see that it's uncommented those out now. The hash at the beginning of each line has disappeared. So that's the way to just uncomment that, and I'll return it back to where it was. There we go. So take the opportunity to run that. Okay, so this uses something called Grid Search CV, which is part of this package. Again, take the time to have a look here. This will contain a lot more information than we have time to cover today. And so once we've done that, with that set of values that so recall, the example of my trip to Brighton with my wife. So the fact that the car is warning me that, drag is increasing because you've got your windows open. When I close the windows, drag is reduced, right? So similarly here, we've got a set of these three things that we've been able to determine the best value for this, particular set of options that we had. And that's helped us. That's given us a model. Then we can then test this model using the test data. So initially we train it. Okay. Here, do the training. And then from that training, we create these predictions. And if we look down here, so we can compare what has it predicted against what was the actual rating. Okay. So this is overall, you can see, well, for these 5 rows, okay, doesn't look too bad. This row looks fairly reasonable. That one doesn't look too bad. I mean, you've got 4 and 4.12. That one doesn't look too bad. That one is not too bad either. The one that kind of stands out is this one. So the prediction, the rating, the actual rating was a 1, and the model predicted it should be about a 3.4. Clearly, that's kind of way out and significantly different from the others. But that's, again, okay. It's just a part of the process of evaluating the model and then looking for ways to improve it as well. But overall, not bad first attempt, I would say. Okay. And then here you saw me mention a couple of things, the root mean squared error, the mean squared error, standard sort of techniques in machine learning. And again, a little bit of an explanation of what these are actually doing to show us and as a means to kind of evaluate the quality of the model, if you like. And so for this RMSE, measures the square root, the average square difference between predicted and actual ratings, okay? Lower values indicate better predictive accuracy. And it's the same for the next two as well. And then finally, we've got this thing called FCP, fraction of concordant pairs. So if we take a look down here, here is what it's been able to give us as part of this iteration in terms of model building, okay? So there are the values that we have. Okay. One of the things that we can do then is there are several other mechanisms available to us to kind of look at the quality of the model, if you like. And that's, the old phrase about a picture is worth 1,000 words. Well, visualizations are good. And so here, what we're doing is we're creating this precision recall curve. Okay, so there's a TLDR again, simple sentence to explain what this is actually doing, and then a longer summary to go into more detail to say what is it that this is actually doing for us and why are we doing this? This notion of kind of precision and recall, again, very important concepts. And so a good classifier strives to achieve high precision and recall, high recall simultaneously, as represented by a curve that hugs the upper right corner of the plot. And so if we plot the data according to what we've achieved here, you can see here, well, it's not too bad. We ideally would like this to be further up here in this direction. It so happens there that as a first attempt, maybe you think, well, that's not particularly good. But again, we could go back. It's an iterative process, evaluate, assess, tune, and so on. Okay. Another mechanism is this thing called the ROC curve and AUC. Okay, again, this is looking at sort of true positive and false positive rates. Again, plenty of explanation of what these are just below there in terms of the summary, standard techniques used in machine learning. And here we've got something that we've plotted, okay, which is this thing here. Okay. So if we take a look at the notes there, it says a diagonal line from bottom left to top right represents random guessing. That is no better than flipping a coin. And a curve closer to the top left corner indicates better model performance. So the AUC, area under the curve, quantifies the ROC curve's overall performance. So if it was 1, that's super. Yeah, absolutely awesome model. That's perfect. If it comes out to 0.5, you get yourself a coin and just flip it. Okay, there's no better than that. And this is what we're seeing here. So in our case, we've got an AOC value here of 0.82. Okay, again, what we would like to see ideally is this closer to this side here. And there's the sort of 50%, which just get a coin from your pocket and flip it, and it will be no better than that. Right. So we've done better than that, at least in this particular case, in this particular example. Again, for a first iteration, in my humble opinion, that's not bad. Okay. And another way, a mechanism that we can kind of assess is this concept of a confusion matrix. Okay. You see this again, very standard way to look at this, what's predicted and what it got right versus the kind of the mistakes that the model has made. And we, in this particular case, well, you might say, hang on a minute, you told me earlier that we had a rating of sort of 1 to 5. How can you do this? Because this is binary in this particular case. Absolutely. So we've set a threshold here of 3.5, which seems fairly reasonable, because if we look at the typical ratings, we can see that 3, 4, and 5 come out quite high. 3 and 4 are the two highest in terms of the greatest number. And so it's not unreasonable, in my opinion, just to start with something that is still kind of sits between the two. And so if we do that, okay, we plot this, we can see here that we've got, the actual, okay, versus the predicted along the bottom here. And so again, we can see that overall, for a first iteration, that's not bad. Now, in some cases, when you're doing this type of plot, let's say you're doing it for fraud detection, okay? Fraud, the thing was an actual transaction that was correct versus a transaction that was fraudulent, okay? And you're trying to build a model to represent that. Well, in the case of, for example, it was a transaction that was correct, but you flagged it as fraudulent, that's a type 1 error, okay? That would be a bit annoying to your customers, all right? But not disastrous. Let's say, though, it was flagged as correct, but in actual fact, that transaction really was fraudulent. That's more serious, okay? That's a type 2 error. That is something that you will really want to avoid. And so in this particular case, again, because it's a kind of a binary classification, overall, I mean, there's no life and death thing here. It doesn't really, it's the fact that we've got errors here, not a big problem. So in the case of this one, for example, where we've got the actual as negative here, majority of those are classed as negative. That's okay. Yes, it has classed a significant number of those as positive, not disastrous. And then in this case, for example, this is positive. And again, if we look at the bottom here, this is positive. So that the vast majority of these have been classed correctly. And again, yes, we've got a significant number here that are incorrect, but again, it's not disastrous. I mean, it's not a life and death thing, right? First iteration, okay, again, room for improvement there. And again, looking at coverage and diversity, then this is looking at the user coverage. I mean, how many of the actual unique users did we look at? And then in terms of the movies themselves, what was the level of diversity that we looked at? And if we look at the output there, we can see we actually used 100% of all the users and about 95.6% of the movies. So again, those are very high numbers. So overall, we looked at a lot of the, the vast majority of the data that we had there. So what do these metrics help? They help assess the effectiveness and inclusiveness of a recommendation system, ensuring it provides valuable recommendations to a diverse user base across a wide array of items. So that's what we're looking for, to ensure that we meet the needs of all of the people, okay? All the different groups that we have, the different age ranges, for example, the different occupations, and so on, and that we covered the majority of the movies that were in the data set as well. And finally, then, what we need to do then after all of that is to say, all right, so what is the actual representation of this data? And the way that we're able to retrieve that here is using this kind of mechanism. Okay, we are looking for this kind of calculation, these factors, the columns that we created in those two tables earlier. And what we're trying to do is to retrieve these from this, as part of the model, and be able to assign then these to particular movies and particular users, so that then this gives us the opportunity to do further analysis and to make predictions using these in the SingleStore database. So essentially, you can see here that we've got vectors, okay? This is what we were trying to get to. So all of that work, and now finally we get to the point where we've actually got these numbers that we can do something useful with. So recall that slide way back at the beginning of the slide deck that I showed you about having an appropriate means that, in terms of the data representation, whether it happens to be text or if it's an image or if it's speech, that ultimately what we want is a representation of that in a vector format. And this is what we have here, okay? And so we do the same here, okay? So we get the numbers here for the movies. We do the same here for the, this is for the users. And then here we do it for the movies, okay? So we get these values and then we merge these with the appropriate columns that we have in the data. And ultimately, finally, we now have this, which is the result of all the work that we've done in terms of the data, in terms of the cleanup, in terms of getting the appropriate, joins, if you like, from the data frames, things like occupation, for example, and now associated with every user. Okay, so let me take a look at this one here, user ID 1. Okay, we now have effectively a representation of that in terms of the choices that they've made, and it gives us the ability to kind of fill in the blanks, if you like, through this set of factors, right? And similarly for movies down here. So we've added that to the end. And now that we have this, we can write this to SingleStore, which is what we're doing here. So just to make sure we start with a clean slate, we just truncate the 3 tables before we go any further. So we start with a clean slate. We don't add data to something that might already be there. And then here, if you decide that that value of n factors, which was 100, as part of this model and as part of what we did in creating our tables originally, you remember those 2 vector columns that we had in the movies table, in the users table, we set the value, hard-coded it to 100. If that for some reason has changed because you have changed that value earlier, for example, maybe you found that setting it to say 150 was better. I don't know, as part of the iteration and the process that you went through. Well, in order to store this, obviously, if you try to store something that's 150 dimensions in something that's been defined as 100 dimensions, it's going to cause errors. SingleStore will complain. It will say, hang on a minute, you are trying to store something bigger than what you've actually defined. So all we're doing here is simply taking the opportunity to just take that value, okay? And then we are modifying what that actually was through this alter table command. And so this will always be up to date. So whatever you set that as, it will always go in correctly, and SingleStore will always have the, create the correct number of dimensions for that, for those two columns in those two tables for you. And then finally, we just write these data frames, okay, the users data frame to SQL using this pandas, okay, and that goes in. So we say, write this to the users table, okay, if it exists, don't be destructive, okay, just append it. We don't want the index, and that's the details of the connection, okay, just above there. And so you can see here that this has got 6,040 rows. And then for the movies data, here we've got 3,883 rows, same thing there. And then finally for the ratings data, it's over 1 million rows here, okay? And that's it, okay? So those are the steps that we've taken. Again, let me be mindful of time. Okay, so we are at 7:40. So let's move on to the last one then. Okay, look at number 4. So after all of that process, we've now got that data into SingleStore. And finally, we can start asking some queries of it within this environment. And so here in number 4, just some example queries for you to play around with, to test. So you recall, I mentioned that we're going to use .product. Okay, so there's the infix notation for that. Okay, and then I happen to know that movie ID 1240 is the terminator. So I was just curious to see what sort of value would it give me. Remember, what we are doing now is we are taking that factors from users, that factors from movies. We're performing a .product upon that, okay? Remember kind of the distance metrics to give us this thing called a similarity score, okay? Now, in this particular case, we don't have anything else to compare with it. We're just asking it for this particular movie. It gives us this value here. This would be useful, okay, if we have other data to compare it against. But this is just a simple example, somewhere to start, okay? For user ID 1, what is the similarity score for them for this movie called The Terminator? It might be, for example, if we compare this against other movies, that may be very low. Perhaps it's something that user may not like. So we can do this then, find top movies for a user based on similarity. So this query finds movies that are the most similar to a particular user based on .product similarity. Now here, we take that previous query a step further and say, okay, how about if we do the same thing? Okay, we take the user factors, we do a .product against the movie factors, again, return a similarity score. And we are interested in user ID 1. Remember, we don't know who this user is. We don't have a name or other details, but we do have a bit of information about their age range, the zip code, for example. And so if we take a look at this and we just order it by the similarity score, so higher is best. So we can see that the movie Airport, for example, 1970, one of my favorites, as it so happens as well. And that gives us the genre, and it gives us the similarity score. So these are the kind of, as it says here, find top movies for a user based on similarity. So these are the recommendations for that particular user then. Okay, and if I look at the genres, this drama appears a couple of times there. We got comedy. So we have adventure. So there seems to be some, genres seem to have some bearing on that. That may be something that's important. And then further down here, well, why don't we take the opportunity to use the information that we have about posters as well as part of that, because that is stored in the database as well. So here, we're just writing a little bit of code here, okay, to render an HTML table just below. So that just gives it a slightly nicer output. So as I mentioned at the beginning, you could easily build a nice front end using Vercel or Streamlit or something that would allow you to enter in, say, a user ID and give you a nice kind of visualization of both the movie and the particular poster, or represent it in whatever form that you want to. And so here you can see we've got exactly the same data, but it's giving us kind of the movie poster as well. And in the event that the poster is missing, remember we handled that a little bit earlier. So in this case, that poster is missing, but we were able to fill that in. In other cases, I have noticed that the actual image is broken. It's probably the URL is incorrect now. So that happens, but that's a case that I haven't dealt with in the code so far. You might think of ways that you could do that, but it might require sort of checking every URL to check that it is actually correct. Or, is it giving me an error, sort of 404 or whatever. Then similarity matrix between users and movies. This query calculates a similarity matrix where each cell represents a similarity score between a user and a movie. Okay, so in this particular case, we are just doing the overall similarity score rather than picking out one particular user. We're just doing everything here. And so we can see here what the highest similarity score is available within this particular model and particular data set is 3.2 for this particular user here, 4539. And actually, we see that this user occurs a couple of times here and here as well. So they are pretty sort of high up in all of this. So we've got Porky's Revenge, Porky's 2, Bride of Chucky, and so on. Okay, these values here are decreasing on the right-hand side here. Recommend top movies for each user. This query recommends top movies for each user based on their similarity scores with movies. Okay, so here again, this is a slightly different take on that. So all of this is user ID 1, for example. And again, looking at the movies, we've seen a little bit of this earlier, and the similarity score as well. Find users similar to Toy Story. So for example, that people like Toy Story, go and find me other people that like Toy Story. So in this particular case, we know that Toy Story, and you saw this from the earlier data frames that we were looking at, okay, it has an ID of 1. So if we take a look at that, we find that the kind of people that like this it seems to be a mixture of gender. Okay, no particular strength there, both male and female. The age range, again, seems to be mostly younger people, I would say, younger to middle age, not really very old people. Occupation, college, grad students, academic, education, programmer, zip code. I don't see any particular pattern there, although I don't have enough information about that. Postal codes in the UK I could probably do, but I think these are US zip codes. Find movies similar to Toy Story. So, okay, take Toy Story, and what other movies are similar to this? Okay, so again, we take a look at this. Unsurprisingly, we find that Toy Story itself is similar to itself, right? We saw that example of that earlier. Toy Story 2, Aladdin, Beauty and the Beast, Little Mermaid, Bug's Life. So these, again, give us some insights into that. Top movies, predicted ratings. And this is an example of where we are trying to predict a new user, the cold start problem. So take someone whose gender is female. They happen to be within this particular age range. And then based upon this, find me the kind of movies that we think they may like based upon what we already know. Okay, and so this is a little bit worrying. Okay, so there are lots of horror movies there. Action thriller. So, and then again, you can see the predicted rating on the right-hand side. So this is trying to help with that problem, okay? So make some predictions for something that we haven't hard-coded specifically, but now we're asking it, saying, well, okay, what do you think would be the kind of things that someone who's a female within this kind of 18, the age range that we've got for that, what would they like to see based upon what we know that other people within that group tend to like. Top average ratings by genre. And then here you can see here, we're taking a little bit of information here. And we can see in terms of the average rating and the number of ratings, again, for the different genres here. So that's not ordered in any particular way, but it is ordered by the rating itself. So typically action, comedy, thriller, sci-fi, war, these seem to come out fairly high, and so on. So user activity overview as well. And then we can take a look at who is the person or the people that, what is the average rating. So for example, here we've got someone who's female. They are within that the age range we talked about earlier. They've rated over 8,000, nearly 9,000 movies, and the average rating they've given for each of those is 3.61, quite high for that particular person, and so on. I mean, you can see that this is no end of fun that you can have here in terms of the kind of queries that you can formulate, and so on. Okay, so I'll stop at that point. Okay, so you can average ratings as well over the time span for this data set, for everything from the year 2000, for example, to 2003. 2000 comes out the best. It's the highest average rating. So there we go. Okay, so we are at 750. Okay, so lots of possibilities there, as you can see. Now, remember, all of this is now stored in SingleStore. We've got all the information that we originally had about users. We have all the information about movies. We now have these factors as well, these vectors that we've created as part of the model building process. And then we can utilize this now using this kind of dot product in terms of determining this kind of similarity score, which can help us in terms of predicting. And as you saw in the case of the female, for example, age range, that one sort of group, we can try to find movies that we might target for a new user, the cold start problem. That could be very useful. Great. Now, finally, let me just wrap up quickly by two quick things for you. So number 5, as I mentioned before, this is using Apache Spark. This uses a slightly different approach. This uses something called alternating least squares, okay? Similar sort of outcome that we're trying to achieve, and but using a different approach in terms of the algorithm. And a word of caution, okay? So this does take a little bit of time. Some of these cells do take a bit of time to run. We cannot write the results of this to SingleStore because the way that Spark outputs those factors, it assigns its own identifier to each row. So there's no way for us to map that back to our original data, which is a bit of a bummer. But essentially, you can see, when we're doing all of this, that the model itself is giving us similar levels of, in terms of predicted results, similar levels of accuracy. We're seeing that all of this is done the same. The coverage and diversity is, again, pretty good. But here, when we generate these factors, yes, we've got the arrays here, you can see. Yeah, these vectors, that's fine. But the problem is that what Spark does is that it allocates its own unique identifier here. We cannot map this back to our original data in either the user table or the movie table. And that's why you see here that it just stops at the end here. We just take the data, and whilst keeping it in memory, we just, again, generate these a set of recommendations based on and do this kind of HTML output table, and then we just stop Spark at the end there. So if you don't want to do this, just put a hash, so that if you run this from top to bottom, you'll need to go back to the beginning again to initiate and get Spark up and running again. Okay. And then finally, let's take a look at 6. Okay, so 6 takes a little bit of step further. Again, optional here. So we create a table and utilize genres. So the reason I created a new table is just to keep the original data intact, not to modify that or not to change it in any way, but to take a separate set of data. And again, utilizing this, what we can do here, for example, is, we can do all the similarity stuff that we did previously, take the user factors, movie factors, do the dot product, calculate the similarity score, which is what we're doing here, for example, but then utilize the fact that we have genres and we can create a full text index on genres. So here, for example, we're looking at movies that contain thriller, but we don't want them to have horror and we don't want them to have sci-fi, for example. And if we do that, we can get back a set of recommendations here, for example. And in this particular case, this score is 1, okay? It's because everything's a thriller there, as you can see. And the score is this that's being generated by the full text search, not by the dot product. You see, we're not using dot product there. Okay, slightly different approach. And then here we can combine both. We can say, okay, do this, do the dot product, do that, factors, calculate the similarity score, and also take the opportunity to do the full text. So we're looking for thriller, we don't want horror, and we don't want sci-fi. So we're now combining the two techniques together, and then that's again providing another level of filtering here. So you can see here that none of these results have horror, none of those results have sci-fi. So those are being filtered out, but we've got thriller and we've got comedy romance sometimes, okay, because those are part of the genre, and so on, okay? So that's entirely possible, okay? So again, we can output the results in a nice format to visualize what this actually looks like. Okay, great. Let's have a look. So we've got just a couple of minutes there. So let me just wrap up then, okay? And so what we used was SingleStore for ultimate storage. We had Jupyter Notebooks, okay? We're using movie data and movie poster data. And by the way, in case you're interested, why did we use this thing called singular value decomposition? It is because of this gentleman here, Simon Funk. Let me highlight his name here, who used this as part of this Netflix prize competition. Okay, and so he used this technique, I believe, and he got the prize. He won lots of money for that. So that's the reason for that. Okay, summary. You saw in the examples the full power of SQL. SingleStore is transactional, parallelism, scale-out architecture. Adding the vectors makes it queryable immediately. We've got hybrid search as well, which we briefly looked at the end there. Okay, that allows us to combine both semantic search, which we're doing using the dot product, combining, taking those vectors from the users and the movies. Speed to match that of vector-only databases. Okay, so the performance results, as I said, mentioned, the VLDB paper, look out for that. Okay, we should hopefully be available to make that publicly available, or at least the results in a format, perhaps as a blog post or something in the very near future. Much faster than PG Vector, Elasticsearch, and so on. Okay, so results done through this research group at Purdue. And so that gives you the ability to, utilize something not just for vectors, but for other types of data as well. And it's a wonderful quote from one of my favorite authors. Any sufficiently advanced technology is indistinguishable from magic. Okay, so I think you've seen this. So Yukti, I think we've done this already. And I think probably you want to announce the winner. The questions, I think we'll happily take, I think, offline. We can do that since we're pretty much out of time. My mouth is dry and I'm looking forward to dinner. So I think we're almost at the top of the hour there.
Oh my God, Akmal, that was a long workshop, but yeah, it was really helpful. And we have a lot of questions.
Yeah.
So quick notes before I
Yes.
announce today's raffle winner. We have amazing webinars that are coming up. So they won't be this long, on
This is
August
unusual.
26th.
Yeah.
But yeah, this was really helpful because you know what? I think anyone can take it offline. Like they can just follow along
Yeah.
offline, like without you as well. So in real time if they are seeing the recording. So yes, the recording will be available. It will be emailed out to you. And thanks for attending. So on August 26th, we have how to talk to SQL data with function calling. And on August 27th, we have a webinar with our partner, Amazon. So achieve near real-time analytics on Amazon DynamoDB with SingleStore. And on August 28th, back on popular demand, we have Beginner's Guide to RAG with Professor Tom Ye, who's from Colorado University. So if any of these topics are interesting to you, RSVP right now, and I hope to see you all there. So Akmal, I think we can take up some questions.
Oh, yes, yes,
Until
sure.
then,
Sure. Yeah.
yeah.
Yeah, go ahead.
So we actually have a lot of questions. So
I think anything
I'll just
related to the environment, again, I can only apologize on behalf of SingleStore. Like I said, I took a screenshot. We've got some feedback there as well, Yuki. I think for the people that contributed to the discussion, we will take those comments and pass those on to engineering, okay? Because I think it's very important we iron out what the issue is and why this is coming up nowadays. And again, my apologies for that.
No worries
Yeah,
at
go
all.
ahead,
Sometimes these kind of
Yuki.
things keep on happening. I mean, what even? I have a question from Robert Hendrickson. How can we
Yes,
take this
Robert.
offline? You can reach us to our team at singlestore.com.
Yeah.
And you can either message me or Akmal on LinkedIn if there's any doubts that you have. And if you want to be assisted with further steps, we can either guide you to the right team, or we can also try to help you. So, all right. So we have one very good question from uh, Andres. They say that how can misspelled words affect the model? For instance, the word butterfly misspelled as like, without the U, butterfly, or like if
Yeah,
there's a single letter instead of a double letter, something like that.
that's a great question. So,
Yeah.
misspelled words. So, what I would say is obviously that's going to have a bearing. Now, if the thing is if you've got a lot of misspellings in your data set, that may well be important. It may skew the results in one particular direction or another direction. So, I think typically what my understanding is, like I said before, I'm not a machine learning engineer, I'm not a data scientist, but what I've seen is that there is this process of data cleanup that you go through and you process and analyze the data before you take it a step further. In this particular case, we were very fortunate that the data set was pretty clean. Yes, we had to load it in and we had to do a little bit of work to get it into the format that we needed. Fortunately, though, there was not a lot of pre-processing that we needed to do. So I think that would be a part of that workflow. It would be an extra step that you would take in terms of checking the quality of the data, ensuring that it's up to the standards that you want. And then, of course, things may creep through from time to time. Things slip through, okay? I mean, it happens, even through automated processes or human error, that happens. But again, because it's an iterative process, we go back, we reevaluate, we take a look and see what is causing the data to skew in one direction or another direction, for example. And we may find that it's because of these misspellings. That could be a reason. But I think typically we would try to avoid that wherever possible, simply because we put the time and effort and energy to ensure that initially what we put into the database at the end of the day is as high a quality of data as we can possibly get.
Sorry, seems like I was on
Oh, no,
mute.
no.
So we have a question. How should I design the schema for storing vector embeddings in SingleStore to optimize query performance and storage efficiency? What are the best practices for indexing vector data?
Absolutely. Great question. So I would highly recommend take a look at the documentation that we have, specifically around vectors, vector indexing. There's some kind of gotchas, good practices, rules of thumb that are available there. That will improve as the quality of our engineering and the improvements that we are making to the technology as well. Look out for blog posts as well. And then specifically, if you are a customer and you are working with us, we will be already doing that with you. And so if that's something they're interested in and you have a project, for example, as Yukti mentioned, just reach out to us, team, T-E-A-M, at singlestore.com. Give us the opportunity to talk to you. We can assign some technical resources to help you understand your problem and then be able to work with you and then be able to give you insights into, the best practices, if you like, or the good things based upon your data set, your requirements, and the kind of queries that you want to run.
So, okay. So we have one question regarding the notebook 5. They say that they were not able to load the notebook 5, which was, I'm assuming it was the last notebook. Do
Yeah.
you have by any chance stored that locally in your system?
The best place to get it is if you just look on GitHub, which is what I'm pointing to now. And if you look here, you'll see that they are all there. Okay, so this is number 5. Okay, so I'm looking at GitHub. So it might be just a corrupt zip file. So here you can see this is all there. And incidentally, I've run all of these notebooks for you so you can see kind of example results of what the output may well look like. Now, of course, it may not render absolutely everything, but you can see the most important results are actually shown there. So you can see the graphics there, which I showed you. And so my recommendation is try and download the entire repo first. Or, you could render this in NB Viewer, for example. Just take the URL at the top here, this thing here, for example. It's in my search bar, for example, if you're looking at this, and then just render that, and then you can see that as well. And by the way, the PDF files for all of these as well are here too. So you should be able to see all of these in this directory here, marked as PDF, okay? I'll try and see what GitHub will do with a PDF file. I think it's been a long time since I've tried to view anything. It's probably going to oh, wonderful. It can actually render it as well. There you go. There's number 5 as a PDF file. Okay, there we go. Okay. Anything else, Yukti? Any other questions?
We actually have a lot of questions, but
Oh,
we are
okay.
almost at the top of the hour.
Anything that you
It's
saw that thought, well, this is a really good question. And
Yeah, actually, there's a lot of good questions that
oh,
we
okay,
have, and
okay.
if we sit, it will take
That
the whole
is not,
night.
doesn't surprise me.
Yeah. So,
Okay.
I
Yeah.
mean, we have one good question from Akib Mir. They say,
Yes.
we will get different, will we get different results if we change the vector type?
If you change the vector type, for example, currently it's set to 32-bit floating point. If you change that to something else, what's stored in the vectors, you need to ensure that that matches appropriately. So in our case, for example, you saw that the vectors being generated were, floating point numbers. If you treat it as, say, 16-bit or 8-bit floating point, you will lose some precision. You need to check that out. That's a great question. I ought to investigate that myself, but essentially try it out, okay? See, it depends on what level of precision you want. You can actually change it to 64-bit. I mean, that's overkill. 32-bit, I think, is fine for most use cases. If you don't quite want that level of precision, maybe something smaller, 16-bit should be okay. But then when you start moving in the other direction, 8-bit, well, you're losing a level of accuracy and precision there. And if you want to change it to something else, say integer, well, again, that's a bad idea, I think. I think for these particular values, you saw that the vectors, we really need arrays, and they are decimal. And therefore, it's important that we have, I think, floating point as the best sort of choice there.
All right. So, I'm very sorry that we cannot take all the questions online right now. So, but please feel free to join our upcoming webinars, and I'm expecting that we might have some time. So we are also planning to schedule a webinar with trillion row processing power of SingleStore, which was really interesting. So Akmal, that was validated FYI by Eric Hansen. So yeah,
was that
yeah,
from Eric Hansen?
that's yes. So
Yes.
he
Yeah.
actually was validating it, and that's actually a thing, and it's working because it was a hypothesis
Understood.
before. So yeah, feel free to join that one. We will put that out on our landing page really
Yeah, it
soon. I
might
think
be just an
between the
FYI to the audience there, Yuki. So
yeah.
Eric Hansen did this trillion row benchmark on SingleStore. I think it was a couple of years ago. And that one, I mean, it's in trillion rows, as you can see, needs a bit of compute power and time to set it up. So we asked Eric if he could repeat that. He could take it a step further. He's like 10 trillion, why not? But all of this requires time and effort. So Eric has actually been working on that, and that's going to be the subject of a webinar. So if you wondered, is SingleStore scalable, I think your mind will be put at rest once you attend Eric's webinar. He'll show you how he did it. And if you really want to run that yourself, I'm sure he'll give you the scripts and the how to generate the data for that as well.
Yeah. So if any of your questions are unanswered and you would actually like us to resolve, so reach out to us at team@singlestore.com, or just feel free to drop in a message to me. I will redirect you, or like we can just take it offline if that's needed. So just I think I've made the announcements regarding the upcoming webinars. So the announcement that everyone's been waiting for, today's raffle winner, it goes to Karsten Gunther. He's the co-founder at Codify. So congrats and thanks for joining. And if
Congrats.
that is not you, do not give up. We are going to announce one more AirPods winner and Meta's Ray-Ban winner that has attended today's session and has signed up using Akmal's code. So if you have tried out today's demo, you are automatically eligible to be entered and to be considered for the raffle. So if anyone that has not yet tried, here's your chance. You can still sign up and be eligible and be entered to win. Thanks, Akmal, for the amazing session, and
Most
thank you for
welcome.
your time. It's really enriching, and we really learn a lot. I'm not from a technical background, but even I can now understand that how mathematics is
Okay, great.
actually used. Yeah, it's actually used in computer science. So yeah, that's definitely a game changer for like a lot of people. So thanks for the amazing content you put out for us every time. And thanks to our attendees. Thanks for joining. I see a question regarding the Slack channel. We don't have a Slack channel, but we do have a Discord.
Yeah, we've got a
Um,
Discord
yeah,
server. Yuki,
that
you might want to send
yeah,
that in a follow-up email as well, because we
actually,
are trying to
yes,
make that more active. So it's a great way for you to
yeah,
interact not only with the marketing team, but with product and engineering as well.
right.
So that is something that we can do. Please join, get involved in the conversation. You'll find me there, my
Mhm.
colleagues as well will be there as well. We'll assist in any way that we can.
All right. So yeah, I've made a personal note of that, and that Discord link will be included in the follow-up emails.
Yeah,
So yeah, thanks for joining, everyone. Take care. Have a great rest of the day
yeah.
and great rest of the night. Take care,
Right.
everyone. Bye bye.
Thank you. Bye-bye.